Welcome back to Space XPLR. We have another episode with, as always, special people, special guests. Today is another episode with another special guest. Today we're covering agriculture, space agriculture, maybe more specific, and how we can grow edible crops while being on Moon and Mars, and probably talking about Mars a little bit more. Any innovations that currently happen in agriculture. I mean, this is a very fascinating topic. Anything regarding to humans traveling to space, human sustainability. So that's an important subject. So I'm very happy to have Davi Souza today. So he's going to be talking about all of that and more. So again, thank you for coming over to the show, and looking forward to just digging into the soil and finding out all these great things that are happening right now in agriculture.
Thank you very much, Mr. Fedrovas. And thank you for your public for having me here and listen more about space agriculture topics.
No problem. Look, happy to have you on because, as I said, it's a very important subject. Again, you're the pro at this, I assume, right? So we're looking to get more insights, and personally myself, I'm very curious to find out what's happening. Again, any type of research that you're working on regarding space agriculture. So again, as a kind of, starting this conversation, I think it will be good to understand, I mean, what type of research are you currently doing in the space agriculture? And maybe with that, maybe you can give a little bit more of your personal background.
Well, I am currently an electrical engineering student here at Federal University of Rio Grande do Norte in Brazil. And once I realized that it's possible to correlate the electrical engineer side, especially on the control and automation side, with agriculture, I got fascinated. Starting that, I never realized that I was doing this thing in space, especially in space. But I started to go deeper and deeper, and I went to Professor Julio Rezende, which was a previous participant here. He's the coordinator of Habitat Marte Space Analog Station. And I came to him and I told, hey, you have an area for a greenhouse. What do you think we put that to start? I'm more on the system side, like how to implement, how to deploy the systems, how to deploy the devices and technological systems inside a greenhouse, inside a controlled environment for agriculture. And then we have started this research over there in the semi-arid region of Brazil. It's a really hot area with high temperatures, a lot of droughts, and it's really challenging. And then we realized that, okay, if we can do that here, we can think how to implement that in space. And so me and Professor Julio, we started with an area of 12 square meters in a greenhouse with one aquaponic system. And then the Habitat Marte greenhouse, which also is called biohabitat. We have more than 160 square meters of area with 3 different systems. And then I went more deeper in the area. I started to looking for studies on the ISS. Also, there is the Eden ISS, which is located in Antarctica, and many other studies. And well, I really got fascinated, and I realized that, okay, this is what I want to do, and I'm getting more enthusiastic with the topic and really go deeper and deeper as I can and as possible.
Fascinating. So look, this is a really good stuff, and again, that you're working on. And I do understand, because obviously I had, Julio on a podcast before. We discussed what's happening in Brazil with the Habitat Marte. I mean, I understand the conditions right now. I mean, that you're facing, I understand a lot. Obviously, I don't want to talk about that on a podcast, what's happening there, but it's really great that you're taking these steps towards making that type of research, even with the Habitat Marte, because I believe all the habitats, same as Georgian Research Space Station, as we're working on right now, is just going to be an additional piece to this bigger picture, which is us as humans going into the orbit, which again, we're doing that right now, and going beyond that, which is to the Moon and Mars, right? And the next step is having that sustainably, living as sustainably, right? So a lot of research has to be done on psychology, physiology, but food, agriculture, there's another spectrum that's very, very important for us to pay attention. So I'm very happy that you're doing your own research in that space. So can you talk about some of those things that you integrated from engineering perspective to make those automated and sustainable solutions for agriculture?
Yeah. I realized that food is also an engineering problem. So us that are engineers, we need to focus on the food systems. We need to bring our expertise in these topics of engineering, how to optimize, how to implement that systems in an efficient way, how to operate with low cost and like saving energy and other resources.
Yep.
And then all of that is expertise. We need to come up, put everything together and just apply. Okay, my background is especially on the sensoring side, sensoring, automation, and microcontrollers. And then I got a prototype at home and started to implement that small prototype for Habitat Marte greenhouse. And I came up with, I called a monitoring and control case. I called also Frankenstein. It was my first project over there. And I built this control unity to bring the data from the sensors like temperature, humidity, these are really important factors that we need to measure inside of a controlled environment. Mm-hmm. But also like considering that the Habitat Marte is located 2 hours from my city and also from the city of Professor Julio. We cannot be there all the time. Yep. So the automation aspect, implementing automation over there, like to put the irrigation system, the water pump to work on, and the lighting systems, the ventilation systems. This is really important, and also to have the measurements remotely and online and in real time. So putting that the sensorings, the microcontrollers, putting that, integrating that with the IoT background, like, okay, we can have the measurement, we can collect data from our cell phone and understand, okay, the system is working well, these parameters are in a good rate, but if we find any disturbances inside of the system, we can, okay, I can just tell to Professor Julio, hey, let's check up that, let's go to Habitat Marte and see what is happening with the system, if it's really necessary. Right. Because if the system stops, we lose the food. So the same perspective can be applied to space. The astronauts will be committed with many other activities. The agricultural activities will be not the main focus in space, like let's say on Mars. So the astronauts will be committed with other biological research, astrobiology, geology, and many other topics. But they need to have an interface to make agriculture easier. Yes. Like we say that it's really common to have agriculture as an activity that is hard. We have the sun really strong over our head. It's really difficult to conduct agricultural activities. But we are in a new era of agricultural side. Let's say on the technological side, we are implementing a lot of technologies that make these things easier, and we can have agriculture like we have a display showing all of the parameters, and it's easier. Like for the astronaut, they just can have a report. Okay, these measurements are good. Throughout the day, we have produced that amount of biomass. It's necessary to like separate the edible and non-edible, like giving some reports, some insights about the system. And for now, I am moving not only for the sensor, but on the data and applying AI and machine learning, artificial intelligence and machine learning aspects like how to integrate that data that I'm collecting from the sensors and how to have more good insights to support even more of the agricultural activities, not only on Earth, but also in future in space.
Very much agree. This is the right step towards the right direction to making that step, right? To implementing AI, which, you know, a lot of people, including myself, still don't understand fully. I know what it means, artificial intelligence, machine learning. It's that those words being thrown around over there, you know, like for the people, most of us, again, including myself, don't know in depth how the technology can work and benefit. We understand to some degree, but again, you know, we have to work towards that, right? Including as much as machine learning and AI type of technologies into agriculture, just because making everything automated, again, is just explaining it in a situation where you see that something is going wrong with the crops. And again, the crops could be affected. You cannot be there present, you're observing that remotely, but still, if you see there are some variations and you need to fix that, you need to go there yourself currently, right? To make that change, which in the future, I do believe you would like to make as much as automated process. So maybe you can talk about that. How do you envision to having this automated process from planting and harvesting? Is it gonna be full cycle process that automation is gonna do everything by itself? Or would still human will be involved with parts of some of the process?
This is a very interesting question, Mr. Fedor. Like, I realized that during my research on Habitat Marte, I believe it will be an integrated thing. It's not totally fully automated system because we still have the psychological side. We know that plants can support the well-being, the psychological, not only the physiological, but the psychological well-being of the astronaut. So they need to interact with the crops, with the system. And this is a thing that it's really important. Like the technology is not to do everything, is not there to do everything. Technology is there to support the astronauts or the farmers.
Indeed. Yes.
So we can have an interface, okay, to collect the data, but it's still necessary to have the greenhouse as an area for the astronaut just to relax and be there near of the green, the plants, you know, that's still necessary. So if we put everything automated, the astronauts will lose this amazing opportunity. I can say by myself, like when I went to Habitat Marte, the biohabitat greenhouse is the best place in the station for me. You know, I call it my living lab, and well, it's a really necessary thing. Considering space, considering the effects of isolation and all of that stuff, it's still necessary to have that interface that is more realistic one, that the astronauts will go there, we see the crops, we will interact. I call it human plant interaction. They will be interacting with the crops, and the system will be there, the automation systems, the technological systems will be there just as a support tool. So this is a thing that it's really important. We cannot have, we actually can have like a almost fully cycle that can be automated, and AI can really support on that. Like AI, as you mentioned, you are not on the background, but it can support on forecasting. We can support on like, okay, we need to do a maintenance. It can support on the appropriate level set points for the systems, you know, and it can be really useful considering space, because we need to know we need to have some predictions on the systems. Like, okay, with that amount of biomass that has been produced, we can have food for 2 months. So is it necessary for the astronaut to start a rationing or not? How much the storage, you know, like if there are some of that variations, the technological aspect will be there to support. But like doing really producing the crop, see that growing, and like interact with the crop is necessary. And we cannot just live there for the technology. We need to play in the game, you know.
Right. So look, as we're discussing the process of tracking the harvest, right? Tracking that the seeds are growing the way that we want to, and we expecting again the food production that we had there as part of the plan. This is the number and this is what's going to happen. Okay, it's going that direction. But what about making the first step? Because obviously I don't think that's going to be the situation that we're going to start delivering the dirt from the planets to the dirt, this dirt to Moon and Mars. So are you doing anything, any type of research regarding planting anything, any sort of a vegetable, you know, any sort of a seeds by using simulated regolith, let's say from Moon and Mars or anything like that? Because soil itself is going to be an issue. So how do you think that problem can be tackled when it comes to growing plants?
Using the regolith, over there in Habitat Marte, we have a volcanic area, which is called Cabugi Peak Volcano. It's an extinct volcano, and there are a lot of basalt rocks over there. So with the basalt rocks, there are some other studies that has been conducted by NASA, by JAXA also. And we started to collect some samples of basalt, and we conduct a geological, mineralogical specification. We have a soil over there. It's near of the neck of the volcano. It starts like the vegetation start to decrease, and we have more basalt. And that soil over there, it's the best one because the basalt rocks are like deteriorated with the time, and that soil has a lot of components that are from the basalt. So we have collected that samples, and we moved that. We came up and we put over there in Habitat Marte. For now, I'm not near of the station. I am in another state. I came to São Paulo, but when I was there, Professor Julio was buying a greenhouse, a small greenhouse, prototype of greenhouse, to start to conduct some research with that soil and see if it's feasible to start producing over there. So we realized it for now that it's necessary to conduct some processing. Like, okay, we still to really mimic the situation of space, you know, make it really analog. So it's necessary we still have some biological life over there with that inside of that soil. It's a thing that we cannot control, but it's necessary to make some processing on the soil, make it more looking like more sand, you know, more feasible to the roots, and making that easier to really grow the crops, because as I mentioned, that soil is still located in a semi-arid region. Is still has faced a lot of droughts in that area. So we have a soil that has changed a lot, and we need to put in a situation that would be the best for the crops. We are still in that phase. We are conducting some research. We are looking for other research that are doing almost the same thing. Another one is another Brazilian researcher, Rafael Loureiro. He's an astrobotanist in Winston State University, and he's conducting a good research with also a Mars simulant. I believe it's as Exolab, produced by Exolab. So he's conducting good research, and he has developed a kind of technology, a small, let's say, a small capsule with some biological samples that support like the microbiome of that soil, transforming the regolith, because regolith is one thing, because it's not feasible to grow crops, and the idea is to transform the regolith in a soil, really a soil that can produce crops.
Right. Okay. So the question now is, obviously, probably more than a few who are watching or listening to this episode seen the movie Martian, right? Probably including yourself. So what do you think will be a good solution, again, to growing something on Mars? I mean, is it going to be just like in a movie? It's going to be the first thing is going to be potatoes, or are we looking for some other sort of vegetables and seeds, and like what are the options, the best options for us to start growing while being on Mars?
That film is awesome. Like it's a good start to go deeper on that topic, you know. For people who doesn't know space agriculture, that film is really good to really present what I'm doing and other researchers are doing. But well, regarding the type of crops, NASA is conducting a lot of research with leafy greens like lettuce, mizuna, and many others leafy greens. This is really good because the life cycle of the crop is like it's shorter. It has a lot of amount of nutrients. It's easier to grow into LED lights, you know. Potato is really interesting, but also I watched a webinar from Dr. Joya Massa from NASA. She's the responsible of veggie, and she told that okay, we still don't have any technology for cooking in space. Like we didn't have a kitchen. We have a dinner table for now, but at ISS we didn't have something to cook the potatoes. So to really process that food, you know. But it's feasible. Like we have many years ago, we have some research of Dr. Raymond Wheeler, another excellent researcher in the area. He has produced potato in a hydroponic system. This is awesome. He had good results, but it's still necessary. Okay, we are in that phase to really move to the, let's say, to the moon and then go to Mars. We have the payload. Payload is money, costs a lot. And it's necessary to start small. We need to develop small prototypes, small systems like that are modular, but also scalable. So I would say for now, from my current experience, I'm working in a vertical and urban farming here in São Paulo. It's a big urban center. Here we call it Pink Farms. And at Pink Farms, we have like in an area of almost 900 square meters, we are able to produce almost 2 tons of food, of leafy greens, especially lettuce. You know, this is huge. You know, and that system are modular and also scalable. It's possible to increase that production in a bigger area and have more amount of food. So we using the vertical solution, the vertical farming solution, this is also necessary to start to put in that systems that idea of modular and scalable. So, and also there are leafy greens, there are okay, the roots, crops, but also I would say the microgreens. This is a kind of crop that are more familiar, are becoming more familiar to us. At Pink Farms, we also produce microgreens. And it's really awesome because the life cycle of a microgreens is 1 week, is are really nutritious and also delicious crops. Like it's small crops that okay, we can have microgreens of carrot, we can have microgreens of many other crops, but they are smaller and it's easier to produce. It's required less amount of lighting. You know, it's easier, it's cheaper, and it's really nutritious.
Right. Very interesting. So again, I love the fact that you're working right now on vertical farming, and I've seen some of the bigger kind of hotels / cafes are doing that in-house as well, where they have vertical farming and they produce their own vegetation, you know, for the food that they do in-house, which I think it's cool. It's just awesome to look at, you know, all these LED lights and just the facility on itself, you know, it's great. And I think this is, you know, a lot of great research can come through that. And again, if implementing something like that in a analog station with aquaponics and hydroponics. So the question that I want to ask is regarding water, right? And maybe we can scratch on our life support systems at least a little bit, because I just want to talk about the closed loop cycle that's happening in the habitat while you're taking a shower. Where does the water go? Is it is that being used for hydroponics? How does the cycle look like? Maybe you can explain a little bit more to the people. Like, how do you envision the scenario of just, using that water, which again, on Moon and Mars, it's going to be very scarce until we're going to figure out how to extract that water, let's say from the, meteor, like from the craters on Moon and Mars, that, water can be trapped in that, kind of icy bottom. What do you think about the just like life support systems and having that closed loop cycle to reuse the water as much as we can while being on Mars?
Well, starting with the system, with the cultivation system, it is necessary to have that closed loop into the system. Okay, we can start with, let's say on Habitat Marte, we have an aquaponics system which produces crops and fish. And it's a totally closed loop system. We save an amount of 90% of water because the water go to the fish, go to the plants, and turn back to the fish tank, and it's closed loop, But if we go, if we expand that idea, even taking the bioregenerative life support system, not only the water, but also the biological aspect of like algae, it's also a useful resource, a useful technology to support astronauts. But regarding to that, the water issue, okay, the shower is a good thing. I would say the gray water, it's more useful for agriculture because it has some nutrients, some rests of nutrients, like, okay, we wash the dish, we have that amount of food that is like wasted. That food is useful. On Habitat Marte, we have a system we call BioMart, and it's a gray water collector, and like we just filter that water. We have some worms over there, and like they just clean the water, like do the mineralization thing, and just deliver the nutrient, the water, the nutritive solution, let's say like that, because it's water with nutrients, and deliver that to the crop. So on the shower, I would say that it's still useful to implement that water in other systems. It's important to look for where we want to deliver that water. We will have different sources, but to close the loop, we can have different closes, different loops over there. But it's necessary a minimal treatment for that water to really go to the system, because even on cleaning side, like we doesn't want to have food on the water of the crops, that food that was wasted. So it's necessary to have a treatment, a filtering system, but that water is really useful to that. Also, algae can be a technological support on that thing. Like algae can do the water treatment that are necessary to provide to be provided to the crops. So I say that on the technological aspect, all of the technologies, all of the solutions are really welcome, especially in space. Like if we, the idea is to integrate all of that thing. How we can integrate all of that technologies, that solutions that are available to us to make things really happen in space, make that system effective.
Yes. Well, exactly. And I think we're forgetting another kind of closed loop system, which is, happening right now in the International Space Station, because obviously they're expecting the payloads, which again, as you mentioned before, it costs a lot, right? To make a payload for any sort of a supply, if it's either oxygen, water, clothing, or food or anything like that, right? That they get delivered. Another closed loop system, that means that you have to drink your pee, which not directly, but it's going to be filtered, right? But again, because water is really scarce while being in space, and obviously you cannot eat for longer that you cannot drink, the water, the fluid, right? So that means using everything that you have, even filtering your pee and drinking that again. If that's what it takes, I mean, that's what we have to do, at least for now, right? So, but I want to talk about another big problem that we have, because a lot of people talking about why do we focus on space, why do we focus on space industry? There's all these problems here in the planet, which of course I do agree 100%. We need to focus on that, but There is a but, as you probably expected, because of the space travel. We as people, we as space agencies, private companies, found out a lot of great initiatives that came through that space innovation. So another big problem, and maybe we can talk about the solutions that could be there, is again obesity, right? Big problem. How do we tackle that? So what the ways you think just doing a research and exploring space and going into space? So what type of technology, or either new foods, maybe algae-based foods or anything like that, they can come up that we as people can consume and have less obese people here on the planet?
Sure. Well, I will start with a good thing that are happening in some analogous stations. Eat cockroaches, like eat insects.
Yep.
So this is a type of cockroaches have a lot of protein. It can be a meal, So it's useful. All of that things that are delivered to space, we already know. We know really well. We are in the sector. That space is here not to like do a competition with sustainability on Earth. We are here to support. We are here to deliver. Okay, we have investments on space technology, but we also have investments to have that space technology available. Like, okay, how we can, if we deliver that, I say that, okay, if we can grow crops on Mars, growing crop in a desert here on Earth, it's easier. It will be easier, to have us that if that system operate well on the Mars atmosphere, it would be operating really well here on Earth. So you said really great. Like, okay, people are saying that we are losing a lot of money, time, energy, like our energy to put that efforts and making things happen in the space sector. But I realized that, especially on the Habitat Marte research, we do the relationship of a semi-arid region, which is really scarce. Like food is really complicated over there. We depend on the drought. We depend on the rain. The droughts didn't allow that, and we need to think in a different way. Okay, I would say the greenhouse aspect. We can like minimize the use. We can like put to zero the use of pesticides. We can grow a bigger amount of crops and deliver that crops. Avoid waste. Like here in a urban farming, I'm seeing that we have, if we like in a normal chain, agricultural production chain, if we have a life cycle of that crop, like okay, after harvesting, we can have 10 days to eat the crop. Okay, if we lose 5 days just to deliver that food to your table, that's not feasible, because you just have 5 days to eat that crop. But okay, if we are cultivating near of the big centers, we can have that crop that it will be available for more time, and it will be avoiding waste. So these things are minimal things that can really support, especially on like to avoid hunger, to support. I would say it's really recently. I believe that the UN has tweeted something like, okay, if we have an amount of the money of Elon Musk, we can avoid with hunger in the world. So he told, okay, if you really show what you are doing, we can do that. Like that's awesome. It's like a space initiative. Elon Musk is doing that for space. Imagine that applied here to Earth, Like, but I also would say that we are the main agents of transformations. Like we have that specific knowledge. We know that space is visible to us. We know that space is here to support. So what we can do for now, let's tell people that space is here to support. Like when I start talking that, okay, I'm researching about space agriculture, people are just like, oh, that's awesome. Why you do not apply that here to Earth? And I say, okay, we have that thing that are being applied, systems that are being applied for space, but we can have a lot of insights how to implement that system here on Earth. So saving water, avoid waste, saving energy, you know, having less labor, you know, like
Yes.
workload. That's also interesting because people will be losing less time in the agriculture, but they can be committed like, okay, my agriculture system is working well. I just harvest and I can come here in like a small market, local market, and just sell it to you. And this will be increasing economy. Like we are migrating. I would say that we are not, we cannot be only sustainable anymore.
Exactly.
The sustainability, like if we continue sustainable, like the impact that climate change are producing are higher. So we need to be regenerative. We cannot stay in a line. We need to increase that regeneration of our ecosystems and all of that. And this can really support that, not only on money aspect, you know, on cost, like support financially, but space can support and many technologies like motivate people. Like I was really motivated with space and space agriculture research, you know, like, and I do not see myself anymore doing anything else. I like, besides the electrical engineering side, the background, I am on the agriculture side. So, but how I can use my background and support agriculture. Space is the same thing. People in space sector has that specific background, but how they can use that background to support agriculture and to support many other things, to face like societal problems at all, you know, not only hunger, but like poverty, education. Like it's for a kid to have that crop growing at school. That's awesome also, you know, like it's really motivating, and it can be changeful. Like it can be changed in like passing the years, you know, like implementing some educational initiatives using agriculture at schools, like for youth, for children, you know, they will be more like familiar with that thing, and maybe they can go to that sector and try to help something. Like it's really common here in Brazil, because Brazil is a country that is really on the agricultural sector. But if we have like families that are doing that own cultivate that own agriculture, like the children of that farmers usually doesn't want to continue that labor, you know. Like, okay, my father is a farmer, I don't want to do that. I want to do another thing. I want to go near to the urban centers. I don't want to stay here.
But, or want to be a TikTok influencers.
Yeah, just like that. Yes. But okay, it's a thing that an economy that their father, like or mother, are conducting, are making happen, and how they can support, like the children can have that idea, like that educational aspect at school, and just, hey father, hey mother, I saw that at school, that can be useful for our cultivation over here. Like they can use that knowledge that they learned at school, that applied knowledge with hands-on also, and just support their family, you know. This is a small perspective, a familiar one, but if we increase that, we can build an ecosystem, like to really cultivate crops that are more healthy, and really support that agricultural chain that we are usually that the common way, you know, like for now. But this will, with the years, this will be not common. This will be like totally unsustainable. We need to, agriculture need to be like faced with a thing that can benefit us, not only on our health, but in many ways, like also to motivate. I got really motivated. I can tell you by myself. This is awesome. Yeah.
That's amazing. So I do agree with you, because again, for you, space agriculture, I mean, that's in your vocabulary now, and it's like, for you, it's nothing new. For a lot of people, this, again, kind of, it's a very new term, you know, space agriculture, what it is, how does it look like? for other agriculture companies, the big ones out there, and maybe even smaller farmers, using geospatial data from satellites, it hasn't been anything new for many years right now, and they're applying that to get better harvesting, better crops. So this is through different base maps and different approach, collecting data samples through satellite imagery of the ground. So this is nothing new already. I mean, this has been implemented through commercial space already through satellite imagery. But again, I do believe that there is a lack of communication. And that's why I wanted to have you today on the podcast, for more people to see and become, so they can implement this word space agriculture in their vocabulary. And so that can become for them kind of just a regular thing. As you're saying, for us, it has to become a regular thing. And we have to understand that because of that research that you're working off, a lot of spin-offs that will be beneficial for people will come up. And again, tackling these big things, as you're talking about Elon Musk and, poverty and hunger, which is, again, a huge problem. Not even, obese people. Probably the biggest problem is, lack of food, right? That's even bigger problem. So how do we can tackle that? Again, it's part of your research, part of the, many people, again, in NASA Space Education, private, individuals or companies, just like you, who are working towards that research. So this is really, really good stuff, and I appreciate you again sharing that today with us.
Thank you very much. It's an amazing topic. Yeah. And as I said, it's necessary to us that we have that expertise, we have that knowledge, to spread that knowledge, not in a technical way. Like it's necessary to be common, like a discussion, a common discussion. Like, okay, if we can talk about politics, we can talk about football, we can also talk about agriculture,
Yes.
like even in space agriculture. Oh my, like it's really common when I talk about space agriculture, people, oh, that film, The Martian, yeah, like you can start over there.
Yes.
Like it's necessary to really common, as you mentioned, to stay in our vocabulary and be more familiar with that thing, that okay, if we doesn't eat well, we cannot think well, we cannot study and have knowledge. It's I think that let's say everything is integrated, like our healthy, our thoughts, our creativity. Like it's really common to me, like, okay, I will eat a salad over here, and I will do not only exercise, but I will do my research over here, like this stimulate creativity and many other aspects.
Yes. Agree. So definitely we need more topics, as you're saying, politics and football and, talking about religion, which again, in Brazil, I believe all these three things are talking about football, because all those three things are just football and religion and politics in Brazil. But look, it's awesome to have people like yourself, who are doing that research. And again, I do recommend for everybody, again, for those who are interested, to get in contact with Davi. You're going to find social media links and his email in the bio. So make sure to do that. Ask him questions about Habitat Marte, analog, missions that they're working on. Get in contact with Julio. He's very approachable. So, connect with those people. If you're in Brazil, I would recommend to do that even more, because obviously making collaborations or just exploring ideas, it's always good, because look, all the habitats out there and the people, individuals who are involved into doing the research and the work that they do, look, we just adding value to this big picture, as I mentioned at the beginning of our conversation. So, and for me, it's all about speeding up the process, right? It's either not even to go into Mars, but, tackling problems while being here on the planet as well. So guys, I hope you enjoyed this episode as much as I did, and make sure to pass it along to your friend, because I mean, this is a great message, and probably is going to be brand new message for a lot of people here. So make sure to do that. Davi, again, thank you for coming over. Thanks for the knowledge, for the time, and looking forward to continue to look behind the scenes. If I got a chance to see what you guys are working on, and just seeing, following on social media, I mean, it's really good stuff. And I wish you a lot of breakthrough moments in your research.
Thank you very much. I really appreciate your words, your support, and also the interest of people, of the public. Yep. Feel free to contact. I'm really viable, and I love to talk about space agriculture. Well, thank you very much.
Thanks, David. Okay, guys, thank you for watching, and I'll talk to you very soon. Take care.